Hello. Thank you for visiting Battelle's virtual booth at the 2020 American Geophysical Union's annual meeting. Let's all hope that next year's meeting is able to be conducted in person once again. You may be familiar with Battelle because of our management of several of the Department of Energy's national laboratories. We also are an independent research and development institute with laboratories and offices located across the United States. Battelle is a 501c3 corporation or a not-for-profit charitable trust. Our mission is to translate scientific discovery and technology advances into societal benefits. This is consistent with the vision of our founder when we were established in 1925. While we are active in quite a few technical thrust areas, we'd like to take this opportunity to introduce you to some examples of our work enabling Earth and near-Earth space science research. I'm Mike Kuhlman, an aerosol physicist by training, and I have the privilege of serving as Battelle's chief scientist for our contract research operations headquartered in Columbus, Ohio. Joining me today in our virtual booth are a few of my colleagues who will introduce you to some examples of our current work. Dr. Paula Mabey joined Battelle from the University of South Dakota, where she had an accomplished career as a distinguished professor of biology. She also served the National Science Foundation as the director of the Division of Environmental Biology in 2015 through 2017. She will be describing some aspects of a program we are proud to conduct for the National Science Foundation, which is called the National Ecological Observatory Network. We also have Mr. Tom Hutchings, who brings Battelle a wealth of experience gained in his years with the U.S. Antarctic program, including serving as the project manager for construction of the IceCube Neutrino Observatory. He will be describing some aspects of our Arctic research support activities for NSF, which we began earlier this year. Finally, let me introduce Mr. Nick Romano, who is a systems integrator and a fellow recovering physicist with a great deal of research experience in polar regions. He'll present a high-level summary of some recent internally funded work that was made possible with a high-altitude balloon launch. Nick, over to you.
Hello, I'm Nick Romano, a systems integration specialist at Battelle, and today I'm going to talk a little bit about some of our recent space science. In particular, I'm going to talk about a stratospheric balloon launch to test an advanced antenna made possible through Battelle's internal research and development program. Using the balloon as a research platform, we attack the problem of size, weight, and power constraints for satellites and high-altitude balloons. Typically, these systems use multiple antennas for communication and telemetry functions. The ability to consolidate these antennas offers an opportunity to reduce swap needs and increase mission capabilities. The differential segmented aperture is an antenna technology that offers the potential to do just that. It's an ultra-wideband, multi-signal of interest RF aperture capable of functioning in multiple roles. Laboratory tests suggested the DSA could offer increased RF performance, but we needed real-world test results. The objective of this project was to launch a balloon carrying a DSA antenna to near space to determine the survivability and performance characteristics of the antenna in conditions similar to low Earth orbit. In order to do this, a payload carrying multiple DSAs was designed and integrated by the Battelle team, and a balloon launch organized to take place in Sisters, Oregon at the Sisters Eagle Airport. The balloon carried the payload to an altitude of almost 37 kilometers, and continuous connection with the ground station provided us a feed of the performance characteristics of the antenna throughout the entire flight. iStar Stratospheric and CEO founder Stephen Peterson were our partners in this research effort. They have extensive experience in ballooning and were valuable contributors at all phases of the project, from development all the way through execution. The payload was equipped with one DSA facing up and one DSA facing down, with both antennas configured to receive multiple signals of interest. Our target signals for this project were ambient RF signals, including ADS-B, GPS, and then also spectral background noise. Sensors inside the payload monitored environmental conditions during the course of the entire flight. Signals recorded were then broadcast back to a ground station on two channels, both 915 megahertz and 2.4 gigahertz. Sisters, Oregon was an ideal place to host our launch, both for the favorable conditions and our established relationship with the local high school. Through the RISE program, high school students are able to propose and execute a balloon experiment of their own design with the support of iStar. We were fortunate enough to be able to have a couple of those students attend our launch, and we were even able to incorporate a small flight computer from the high school into our payload. The components of our launch system are actually fairly basic. We have an 8,500 cubic meter balloon inflated with helium lift gas, which was more than capable of bringing our payload up into the stratosphere. Just below the balloon, we have the terminate system, which is used to end the flight and initiate the descent of the payload and flight train. Below the terminate, of course, is the parachute and the tracking to accommodate slow descent and locating the payload when it reaches the ground. And then at the bottom of the whole rig, of course, the science instrument package with the DSA antennas. Launch operations took place on a bluebird day in mid-October with very little wind, very favorable conditions for launching, and essentially constituted laying all of the components out in a neat and organized way at the airport airstrip, connecting and checking everything, and then inflating the bubble. With the bubble inflated and NOAATM's permits in place with the FAA, we're ready to launch. So this is a brief recording of releasing the bubble and allowing the balloon to begin its ascent. This graphic provides a good visual representation of the balloon's ascent and flight. We anticipated it would head east out of Sisters, Oregon, and it behaved accordingly, moving away from more populated areas around Bend and flying out into more remote regions in eastern Oregon. The duration of the flight was approximately 2 hours, which gave us plenty of time up in stratospheric conditions to test the DSA. We ultimately reached a max altitude of approximately 37 kilometers. Taking advantage of the fact the balloon was over very remote terrain, we chose to terminate the flight and allow the payload to descend where we knew it could land safely and then be recovered. Although the goal was to test the DSA, we were all very excited to get some beautiful imagery from the stratosphere. The flight was very successful and initial performance results from the DSA positive. All signals of interest were captured by both DSAs, and successful broadcast link was maintained throughout the flight on the 915 megahertz channel. The ADS-B signal being the highest priority signal, we were able to connect with 172 different ADS-B sources, each being an aircraft in flight, and gathered a total of 60,000 ADS-B data messages representing the location of those different aircraft. So the plot actually shows the balloon's flight path in blue, and then each of the 4 different colors of dot represents the progressive locations of an aircraft based on the ADS-B signals that we were able to receive. Of course, we extend our thanks to our partners in this project, both at iStar and the accommodating people at Sisters Eagle Airport. Thank you very much.
Hello, my name is Thomas Hutchings, and I'm the Deputy Program Manager for Battelle's Arctic Research Operations Team, providing support and logistics services to researchers for the National Science Foundation's Arctic Research Support and Logistics Program. The RSL program supports the fieldwork of research projects funded through science programs in NSF's Arctic Sciences section. The RSL program was created to make Arctic fieldwork safer, more efficient, and more cost-effective. Our scope of services include facilities construction, operations, and maintenance, logistics support, direct researcher support, and of course, health and safety support and training. The ARSLS program operates primarily in Alaska and Greenland, but sometimes in Russia, Svalbard, other Arctic nations, and includes ship-based support, such as the Mosaic expedition. Battelle ARO is the prime logistics contractor for the RSL program. The NSF encourages researchers to make use of services provided through the RSL program by working with Battelle ARO. Battelle was recently awarded the Arctic Research Support and Logistics Services contract, and we completed transition in September of this year, with expected performance through 2032. Battelle and our teammates are excited to offer research support in the Arctic while building healthy and sustaining relationships with researchers, vendors, and communities throughout the region. Who is the Battelle Arctic Research Operations Team? Battelle is a nonprofit global research and development organization committed to science and technology. As the prime contractor, Battelle provides overall program management, controls, and leadership. Battelle ARO includes 5 primary teammates that together with Battelle function as a single entity. Our teammates include Polar Field Services, or PFS. PFS has over 20 years of experience supporting science in the Arctic, including science planning and support, operations support, facilities maintenance and construction support. San Diego Supercomputer Center, or SDSC. SDSC has extensive IT experience and are driving the Battelle Arctic Gateway, which is our IT portal, and will be providing other IT services such as business systems hosting and application integration. Stantec brings outstanding architecture and engineering expertise with vast polar experience. The University of Colorado's School of Medicine, UC-SOM, has over 5 years of supporting science in the Arctic experience, including telemedicine support and field medic support. Utqiagvik Inupiat Corporation, or UIC, has over 20 years of experience supporting science in the Arctic, also including science planning and support, operations support, and outreach and engagement. The Battelle ARO team functions as a single entity using a one-team, one-mission mentality. What makes Battelle ARO so special? As I mentioned, first, over 20 years of experience directly supporting researchers across the Arctic, combining over 80% of the incumbents' experience with an infusion of additional expertise in engineering, information technology, and polar program management. We bring an emphasis on outreach and engagement that enhances communication between researchers and communities, encourages respect for traditional knowledge, and brings sustained relationships consistent with NSF's Code of Conduct in the Arctic. Our focus on excellence and innovation that unites best-in-class practices with fresh perspectives to tackle the challenges of supporting the next generation of Arctic research and facilities. Typical activities that are supported under the ARSLS program include start-to-finish support for over 100 to 200 field projects each year. The Battelle ARO team works with researchers to help define support requirements, plan, budget, schedule, and manage each project through completion. Operations, maintenance, design, and construction of facilities required to support research, including the Toolik Field Station in Alaska and Summit Station in Greenland. Management of required procurements, reporting, compliance, program quality, environmental compliance, and of course, health and safety. Currently, we're in the process of planning for the 2021 field season. After a scaled-back season in 2020, due to COVID, we are preparing for what could be a full and dynamic season in 2021. Working with the NSF, we'll be doing everything possible to ensure that NSF-funded research is not a vector for transmission for COVID into Arctic communities. COVID precautions, being incorporated into each and every project plan, will meet or exceed local government directions. The Battelle Aero team brings a wealth of experience and innovation to the ARSLS program, enabling science in one of the most sensitive environments on Earth and supporting operations and facilities in what can be some of the least hospitable locations. Our primary goal is researchers' safety and success. Thank you.
I'm Paula Mabey, Observatory Director and Chief Scientist of the National Ecological Observatory Network, or NEON. NEON is a large facility of the National Science Foundation, funded through their Directorate for Biological Sciences and operated by Battelle. What is the National Ecological Observatory Network? NEON is a continental-scale, long-term, 30-year, ecological observatory. This facility provides free and open data and samples on the drivers of and responses to environmental change, provides a standardized and reliable framework for research and experiments, and it enables data interoperability for integration not only across that network, but also with national and international network science projects. NEON is unique. It's an observatory that's distributed across the U.S., including Alaska, Hawaii, and Puerto Rico, with 81 field sites, both terrestrial and aquatic, representing 20 broad ecoclimatic domains. NEON provides a highly coordinated system of open data for monitoring 181 critical ecological and environmental properties, or data products, at multiple spatial and temporal scales. Because of the long-term time period, these data will be key to addressing fundamental questions pertaining to the drivers' responses to environmental change. NEON data are collected using 3 different systems. Automated instrument systems, which include meteorological and eddy flux data from towers, phenocams, soil sensors, ground and surface water sensors. Observational sampling, which encompasses all the observations and physical samples typically collected by people in the field. These include data from small mammal trapping, ticks, mosquitoes, ground beetle sampling, etc. And finally, the airborne observation platform, which is remote sensing using light aircraft carrying instrument payloads to gather photos, LiDAR, and hyperspectral data. The data collected through these 3 systems may be studied in conjunction with each other since they're collected in close proximity at each field site. The data are also comparable across ecosystems and field sites, which means researchers can study connections and patterns and develop models to forecast environmental trends locally, regionally, and even at the continental scale. At the same time as NEON is advancing research by monitoring and providing this large set of free and open data and samples, it's also a platform that can be used by researchers for their individual projects by using our Assignable Assets program on a cost-recoverable basis. A PI can request the use of a mobile deployment platform. So these self-contained mobile sensor arrays can be set up to collect sensor data that the same sensor data that NEON towers do. And these platforms are designed for rapid deployment to be able to capture stochastic ecological events such as fires and floods across the landscape. Secondarily, access to sensor infrastructure at field sites can be requested. Investigators might want a sensor added to existing NEON field site infrastructure. Researchers may also request access to observational sampling infrastructure at field sites, for example, a field technician's support for their project. Or they may ask for airborne observation platform surveys to collect remote sensing data at sites or at times of year when NEON is not collecting. The assignable assets, in short, are an important way that Battelle encourages the collaborations with the science community through research partnerships. Here is an example of where Battelle leveraged its internal research and development, the NEON Assignable Assets program, and external researchers from the Los Alamos National Lab, with a distributed acoustic sensing technology from the commercial company Silixa. The study was to demonstrate the feasibility of using distributed acoustic sensing along with existing optical fiber infrastructure. We used one of NEON's terrestrial research sites in Domain 10, Colorado, at the Central Plains Experimental Range, to try to extract acoustic wave signatures of identifiable origin. So distributed acoustic sensing is actively used by the oil and gas industry for pipeline monitoring and seismic activity, but using it with existing fiber infrastructure for other uses, novel uses, is emerging. So this technology basically uses fiber optic cables to collect the acoustic data by sensing disturbances in the fiber that cause variations in return signals called backscatter. The backscatter patterns can be analyzed, transformed back into acoustic information that can be used to identify seismic events, foot and vehicle traffic, and even animal movements. In this slide, the larger background image shows the layout of the NEON site, with the instrument hut at the bottom next to the meteorological tower. There are 5 instrumented soil arrays that spread out from the instrument hut to the northwest. Along the path of the soil array is a fiber optic cable used to send back soil array sensor data to the instrument hut. It's this existing fiber optic cable that was used for this study. The results from this experiment are shown here. The x-axis is time, and the y-axis is the total distance of the fiber optic cable as it extends from that instrument hut. The pattern at the top of the graph is someone walking along the path of that soil array. You can also determine a person's speed based on the time delay and distance between each footstep. So you can now begin to imagine how using already existing fiber optic infrastructure, as it exists at NEON, for example, could be used to study a whole bunch of things. For example, the presence, movement, even the identity of mammals as they cross NEON sites. So this is just one example of some emerging research that's going on at Battelle, and an example of how NEON infrastructure can be leveraged through partnerships in both the scientific and commercial realms to advance science and technology. The NEON project at Battelle is actively involved in STEM education and outreach. Our STEM goals include promoting and facilitating public understanding of ecological science, educating the next generation of scientists, enhancing diversity of ecological research and education communities, and providing tools for students, educators, and decision makers to use NEON data to make informed decisions about ecological issues. In sum, NEON's data-driven educational resources support a scientifically literate society by engaging scientists, students, educators, citizen scientists, and decision makers in exploring continental-scale ecological questions and contributing to new scientific discoveries. As a grantee of the National Science Foundation, we're committed to broader impacts. In the past year, we've provided outreach and data skills training to students at undergraduate and above levels across the nation. One example, with the increase in need for online teaching materials, particularly those that included both field ecology and data science, NEON and the Ecological Research as Education Network, in short the ERIN network, collaborated to secure funding for the development of online teaching materials to be ready for this fall semester 2020. In fact, they were ready, and the modules that we developed together have been implemented by many faculty in their classes. 4 learning modules of note include mosquito surveys along anthropogenic impact gradients, backyard pollinator survey, plants in the human-altered environment, and another one on lichen presence and abundance in diverse landscapes. So these have provided a great teaching resource for many professors in this time of restricted access to field studies. Finally, with NSF funding, NEON led the development of the Environmental Data Science Inclusion Network, EDSIN. This network is dedicated to promoting diversity, equity, and inclusion in the environmental and data science fields, and it bridges 2 of NSF's big ideas, harnessing the data revolution and NSF includes. Through meetings, a webinar series, and work with network partners, NEON has significantly increased engagement with minority-serving institutions and other organizations serving underrepresented groups in STEM. This is only a part of what NEON does for STEM, and just a part of the broader Battelle STEM landscape. I'll hand this over to Mike now. Thank you.
Thank you for that, Paula, and thanks to Tom and Nick for their excellent overviews. The examples of STEM-related activities that were just shown as part of our NEON program efforts are a really great fit with Battelle's corporate philanthropy. The proceeds from our work across the Institute are distributed to STEM-focused activities in the communities where our staff live and work. For example, in Columbus, Battelle established and funds an alternative high school with a focus on STEM education. And during this year of the pandemic, Battelle increased our charitable distributions, matching all employee donations to worthy causes on a 3-for-1 basis. And we also contributed several hundreds of thousands of dollars to nonprofit food banks in our various communities. So in closing, we hope that this presentation gave you a bit of an understanding of what Battelle is, knowing that it might be new to you. We also hope that you'll be interested in one or more of the presentations of some of our scientists who are virtually here in the technical sessions. We thank you for your attention and invite you to visit our website to explore Battelle further, where we believe it can be done.
Well, hello to those of you who have made it this far through the presentation, and thanks for your attention. We do have a couple of us online here to address any questions that you may wish to offer. Our intent was to provide an overview of a few examples of some of Battelle's efforts at studies involving the earth sciences and advancing our understanding of the environment and ecology, as well as our foray into near-Earth space science with the balloon launch that you just saw a nice little video from. Battelle, I have been at Battelle now as a scientist and manager of some sort for the past 41 years, and currently I'm serving as the chief scientist for our contract research operations. Some of you in the audience may be more familiar with Battelle from our management of the national labs, which is kind of a separate arm of Battelle. It's all part of the same institute, but what you saw here today was was exclusively actually from our contract research operations. So we thought that's a side of Battelle that the scientists who attend AGU may get less exposure to historically. So I'm hopeful that you all can access a keyboard and pop any questions you wish to us. And if those of us who are currently logged in are not able to address it, we certainly will identify the right person on our staff to do so. Back in Columbus, which is where our headquarters are, we have about 3,200 staff, scientists and engineers and technical specialists who serve Battelle and serve our clients through contracts with Battelle. So I'm hoping that we do get some questions from the audience, and that really hoping that you do have the opportunity to attend some of the presentations at the AGU meeting that are being made by some of our scientists, mostly connected with the NEON program, but there are others also connected with some of our carbon sequestration work and other aspects of Battelle's work in the earth sciences. The being a not-for-profit research organization is an activity. It's a type of an organization that drew my attention leaving graduate school. for a place to advance science and be engaged with the research community. Battelle has a mission of advancing science and technology to the end of societal benefits. And what we are, I think, particularly good at is enabling science. I don't know if you caught that theme through the presentations here, but the NEON program that we conduct for the National Science Foundation is not aimed at Battelle scientists publishing our research using the NEON Observatory, but it's actually actually exclusively focused on enabling researchers across the world to make use of the observatory. So by providing high quality data and making it freely available, we are in the process of democratizing ecological research across the world. So that is especially exciting to me because I think it presents a whole new paradigm in that young and early career and mid-career scientists have access to data they could never hope to collect on their own, but through their analyses, they can provide insights to others, making use of the data, and ultimately redirect the observatory in some directions that are more useful than the original design that at this point is perhaps 10 years old, maybe longer than that in some cases. So by enabling others to perform research, with that being a theme, you heard Tom Hutchings speak to the Arctic logistics program, where we see to the needs of the researchers who are supported by the National Science Foundation to conduct Arctic research. We're currently in the process of assisting the NSF in providing COVID testing in Greenland to support deployment of research teams into Greenland during the next research season as it evolves in the spring. So we're happy to be doing that and able to deploy test methods that actually Battelle developed in collaboration with the Ohio State University. And we secured emergency use authorization from FDA for the application of the Battelle developed test methods. So it's a way to address the shortages that the commercial market is unable to satisfy right now. But it all fits into the theme of enabling others to perform the research activity. Battelle's responses to the COVID pandemic have been effective while challenging. And as you can imagine, if we are trying to put our staff out into the 81 field sites that Paula mentioned in her talk, we were subject to the vagaries of local responses across this country and to the local situations and hospital saturation, availability of healthcare, as well as seemingly arbitrary at times local and state regulations governing our activities. So by maintaining a close watch on all of the parameters impacting our field operations, we had to go through, Paula had to lead our team actually through the effort of assessing how can we conduct our work safely and how can we conduct work in a way that does not put the communities we work in at risk as well. So we had on the website for the NEON program a continuing tally of which sites were up, which were not open at all, and which were operating in a limited or a somewhat restricted manner to ensure the safety of our staff. We've been quite successful in that we've had only one of our staff who contracted COVID, and that was not a result of a workplace exposure, nor did it spread into our workforce. So it's quite challenging and places us in a position of uncertainty as we go forward into 2021, despite the advent of the awaited vaccines, which will obviously be a great start at stemming the pandemic. But we do, in the NEON program, we are now addressing the various modes that we will execute to take to staffing these 81 field sites with technicians during the year. We hire over 200 staff each year to man the sites and to perform those measurements which require boots on the ground to take care of, as well as instrument maintenance and calibrations to ensure that the data we're acquiring remain top quality throughout their entire history and processing and archiving in the NEON program. So either everybody has left or folks are too shy about addressing questions via the chat function. I will encourage any of you to visit the Battelle website and, by the way, to visit the Neon Science website. It's neonscience, all one word, .org, which is a pretty neat portal into that program. We just had a little photo contest for our staff to enter their photographs from many of the different domain sites into the program to use. Neonscience.org. Thank you, Lisa. It's a recently revamped and continuously evolving website, which also tries to track the meaningful research that is being published based on some use of NEON data in the various fields that we support. But that and the Battelle.org site both give interesting views of the current activities in both of the organizations. NEON itself encompasses about 500 staff, so it's clearly a very major program and one that we operate with pride, and it gets a great deal of attention. So do encourage you to take a look at those sites. There are mechanisms on each of them to post questions as well. And if questions come up at some point after the end of our time here, please do feel free to, are encouraged to submit your questions, and we will definitely get back to you with the best answers that we can find. I'm not that great at ad-libbing here to fill the remainder of this time, and I don't really want to trouble you to spend more time here if you don't have further questions that we can address. I hope you find your attendance at AGU in this unique time period to be valuable and to assist you in your research activities and in your development. I know I'm trying to do the same, interspersed with my work duties here at home. With that, let me close out our session here and I encourage you to visit our booth in the appointed times during the AGU sessions this week, and also to direct you to the websites, battelle.org and neonscience.org. And thank you very much for your attention.